Imagine staring across the endless dark at a steady distant light and watching it almost vanish in a single heartbeat of cosmic time. 440 light years away, a star named Epic 204376071 dimmed by nearly 80%, as if something vast and unseen slid silently across its face. One day it was there, the next, it was a shadow of itself. What could hide a star so completely, and why have we only seen it happen once? Epic is a faint but fascinating M-type red dwarf, a star far smaller and cooler than our Sun, tucked away in the Upper Scorpius region of the Scorpio-Centaurus OB Association. At just 10 million years old, it is a newborn by stellar standards, still wrapped in the lingering shrouds of the cosmic material from which it was born. It lives in a bustling stellar nursery, the Upper Scorpius subgroup, a place teeming with other young stars, protoplanetary disks, and the slow dance of planetary formation. It was during NASA's Kepler Space Telescope's extended K2 mission that astronomers first noticed something strange. Over an 80-day observing campaign, Kepler's instruments recorded an anomaly so striking that it stood out from the countless light curves in its vast database. Young stars often flicker and flare, but this was different. A sudden asymmetric plunge in brightness by an astonishing 80%. This was not the signature of a star in turmoil, it was the unmistakable trace of something passing in front of it, and whatever it was, it had to be enormous. The dimming unfolded with an elegance that was almost unsettling. Over the span of a single day, Epic's light dropped in a steep, almost precipitous decline, before beginning a slower, drawn-out recovery. This wasn't the crisp, predictable signature of a planet's transit, the kind of symmetrical dip astronomers can model with mathematical precision. Instead, the light curve was lopsided, jagged in its descent, and oddly smooth in its return, as if whatever obscured the star was uneven, amorphous, or partially transparent. To put it into perspective, the drop in brightness wasn't just dramatic, it was colossal. Most known exoplanets cause a dimming of less than 1%. Even the largest gas giants we found block only about 1 to 2% of their star's light. Epic's mystery event stole away 80%, a magnitude so vast it defies easy explanation. In practical terms, if our Sun were to dim by that much, the Earth would be plunged into near total twilight. The shape of the light curve hints at a complex structure. The steep entry could suggest a dense leading edge, perhaps the front of a massive dust cloud, or the rim of a colossal ring system, while the slower fade-out might mean the trailing section was more diffuse. Some researchers have even speculated that such an asymmetric profile could point to an object surrounded by a trailing debris field, like a comet on an unimaginable scale. What deepens the mystery further is the silence that followed. Follow-up observations by both professional and amateur astronomers have yet to capture another event like it. No periodicity, no repetition, just one fleeting shadow in an ocean of light. Was it a one-off cosmic accident, or is it part of a much longer cycle, one so slow that we may not see it again for centuries? In astronomy, sometimes the most tantalizing clues are the ones that appear only once, leaving us with nothing but data, speculation, and the ache of unanswered questions. One possible explanation is a massive dust cloud, a veil of fine particles expelled by a still-forming planet or moon. In a young system like this, worlds are violent places, their surfaces racked by volcanic eruptions, asteroid impacts, and constant bombardment from debris. Such events could throw clouds of material into space, dense enough to block a staggering amount of starlight. But dust disperses quickly, and for such a dramatic dimming, the cloud would have to be unusually thick and cohesive. Another contender is a gigantic ring system, not unlike Saturn's, but on a scale that boggles the imagination. If a brown dwarf or super Jupiter were encircled by rings hundreds of times larger than those in our solar system, they could cast an immense shadow. Such rings could be the remnants of a shattered moon, or the accretion of dust and ice over millions of years. Yet these structures are delicate. Maintaining their shape and density long enough to produce such an event raises questions. Then there's the idea of catastrophic collisions. In a crowded stellar nursery, planets and protoplanets frequently cross paths, sometimes smashing together in world-shattering impacts. The debris clouds from such collisions could briefly cloak a star, but again, the challenge lies in explaining why we've seen no repeat. Was it a single collision, perfectly timed with our brief window of observation? Each theory offers a glimpse into the chaos of young star systems, but none fits the puzzle perfectly. That perhaps is what makes Epic so haunting. It refuses to be neatly explained. Beyond the realm of the natural lies the unsettling question: could this have been artificial? A fragment of a Dyson Swarm, a partially built stellar energy collector, or an immense construct drifting through interstellar space? The asymmetric profile could be explained by an incomplete structure, or one damaged and trailing debris, the fading light caused not by gas or dust, but a shadow of alien architecture. If we imagine a civilization advanced enough to manipulate the light of its parent star, the possibilities widen. A megastructure could be designed for energy collection, climate control on orbiting worlds, or even as a defense shield. It could be an incomplete project abandoned millennia ago, now drifting silently through space. The trailing material might be waste, construction debris, or even smaller autonomous machines functioning as part of the whole. SETI researchers tread carefully, knowing that extraordinary claims demand extraordinary evidence. They often begin by exhausting every natural explanation before even whispering the word alien. But anomalies like this are exactly why SETI maintains vast light curve archives, to catch these fleeting oddities and revisit them when new data or better technology emerges. If artificial, the implications would be staggering. This would be more than just proof of extraterrestrial intelligence. It would reveal a level of engineering ambition far beyond our own. A civilization capable of building on such a scale would be operating at or approaching Kardashev Type 2 status, harnessing the energy output of an entire star. And yet, if such a construct was only partially complete, damaged, or abandoned, it may tell a story not just of technological triumph, but of collapse, disaster, or retreat. It's an intoxicating thought, and one we must hold with both fascination and skepticism. For now, it remains a shadow in the data, a whisper in the light, waiting for the day when either the star dims again, or we are ready to understand what we've already seen. Events like this are reminders of how much we have yet to uncover. They stretch the boundaries of our models, forcing scientists to re-examine the early stages of planetary systems. Even without invoking alien technology, such observations refine our understanding of dust dynamics, orbital mechanics, and the volatile nature of young stars. They reveal that the processes shaping worlds and systems can be more violent, unpredictable, and varied than we once believed. But there is more at stake than science alone. Unexplained events like this could push humanity to expand its curiosity beyond the safe, familiar edges of our knowledge. They are rallying points for innovation, spurring the development of more sensitive telescopes, new data analysis methods, and collaborative networks across the globe. In a very real way, each mystery star acts as a catalyst, accelerating our technological and intellectual evolution. And then there is the human element, the poetry of the unknown. For as long as we've gazed at the night sky, we've wondered what lies beyond. Each unexplained dip in starlight is an invitation to imagine, to picture vast alien architectures, strange cosmic events, or natural phenomena we've yet to classify. In the quiet between data points, the mind roams free. Whether the cause is natural or artificial, Epic forces us to confront the vast scale of the universe and our place within it. It reminds us that even with all our instruments, all our algorithms, and all our ambition, the cosmos still keeps secrets, and that perhaps it always will. That is not a limitation, but a gift, a reason to keep looking up. For one day, a young red dwarf hid most of its light from the universe. Whether it was dust, rings, or something stranger, the truth drifts somewhere in the dark. What do you think passed between us and Epic? Could it have been natural phenomena, or the fingerprint of something artificial? Share your theory in the comments. If you enjoyed exploring this mystery with me, don't forget to give this video a like. It helps the channel grow and tells the algorithm that you love space mysteries. Subscribe if you haven't already, and hit the notification bell so you never miss the next journey into the unknown. Until next time, keep your eyes on the stars and your mind open to the possibilities.